All right, let's get into it. We're about to break down two of the biggest ideas in all of machine learning, supervised and unsupervised learning. By the end of this, you'll get how we teach machines to think, and maybe even more interesting, how they sometimes learn to find surprising things all by themselves. Let's do this. You've probably wondered this, right? It feels like actual magic. You snap a photo and boom, your phone knows if it's a cat or a dog. But it's not magic, of course. It all comes down to how the machine learned in the first place. And that learning process typically follows one of two main paths. To make this whole thing stick, we're going to use a really simple analogy. Think of supervised learning, like a student with a teacher who has all the answers. And unsupervised learning, that's more like a detective who has to sort through a pile of clues to solve a mystery. Let's go meet the teacher first. So first up, let's talk about the teacher. This whole approach is about learning from examples that already have the answers figured out. Imagine a machine is basically in a classroom with a perfect textbook and a very helpful teacher. The magic words here are labeled dataset. This is everything in supervised learning. The data we feed the machine is already tagged, with the correct answers. It's just like you're giving it a giant stack of flashcards. This picture is an apple. This one is a banana. The answers are there from the very start. And this is a great way to picture it. You're feeding the algorithm tons and tons of images, and every single one is explicitly labeled for it. This is a fruit. This is not a fruit. By seeing all these correct examples over and over, the model starts to pick up on the patterns, the colors, the shapes, the textures that scream fruit. It's just learning from that perfect answer key. So what's the whole point? Well, it's all about prediction. After all that training with the answer key, we want the machine to be able to look at something it's never seen before, like a new picture of a banana, and accurately predict what it is. And this prediction thing, it usually comes in two main flavors. First, there's a regression model, which is for predicting a number that can be anything on a continuum, like the future price of a house. Then you have a classification model, which is all about sorting things into neat little boxes. It decides if an email is spam or not spam, or if an employee gets a raise or no raise. One predicts a value, the other predicts a category. Okay, that all makes sense. But what if you don't have that perfect answer key? What if you've just got this giant, messy pile of data with no tags, no labels, no answers at all? You can't really call a teacher if you don't have a textbook. So who do you call? Well, that's when you bring in the detective. This is the world of unsupervised learning, where the machine's job is to make sense of all that messy, unlabeled data all by itself. And the absolute key difference is right there, unlabeled data. Unlike our teacher, the detective has no answer key. Basically, the algorithm gets tossed into the deep end with a jumble of raw info and has to figure out the patterns and the structure completely on its own. Now, this diagram might look a bit intimidating, but the concept is actually pretty simple. You start with a big mess of data points. The algorithm, our detective, sifts through all of it and starts grouping together the things that seem to belong together. It's basically saying, all these points over here seem to share some kind of trait, so I'm going to put them in a group or a cluster. It makes up the categories as it goes. So you see, the goal here isn't prediction at all. It's about discovery. It's about finding surprising groups or relationships in the data that a person might have never, ever noticed. So what does our detective actually do? Well, two classic moves are clustering and association. Clustering is how you might group customers into different marketing segments based on their shopping habits. And association finds cool rules, like that famous finding that, hey, customers who buy bread are also really likely to buy milk. These are the kinds of hidden gems it's looking for. All right, so we've got our teacher and our detective. Now let's put them side by side and really nail down the differences once and for all. This table just lays it all out perfectly. First, the data they use. The teacher needs that clean, labeled answer key, right? But the detective works with the messy, raw evidence. And their goals? Totally different. The teacher is all about predicting what will happen. The detective just wants to discover what's already there. And that's why their main tools are different too. The teacher uses things like regression and classification, while the detective uses tools like clustering. Okay, so teacher versus detective. Why do we even care about this distinction? Well, this isn't just some academic thing. It's the foundation for how we solve thousands of real-world problems. Because knowing the difference is all about picking the right tool for the job. If you want to predict a future outcome, like forecasting the weather, you need a teacher. But if you want to discover a hidden pattern, like finding brand new groups of customers you didn't know existed, you bring in a detective. Choosing the right approach is step one. And this kind of leaves us with a big question for the future. The teacher is amazing, but it needs us humans to do all that tedious labeling. The detective, on the other hand, can just swim in the endless sea of raw, unlabeled data we're creating every single day. So, who do you think is going to be more important down the road? The one who needs the answers given to them, or the one who can find them on its own? It's definitely something to think about. Thanks for tuning in.